Good morning, champs. Today we introduce one of the most important ideas in engineering statics, distributed loads. Many students are comfortable with point loads. Then a distributed load appears and suddenly everything looks unfamiliar. The good news is that distributed loads are not a new kind of physics. They are simply forces spread over a length. The units are force per length, such as kilonewtons per meter or pounds per foot. The big idea is simple. A distributed load consists of many small forces acting next to each other. Instead of working with hundreds of tiny forces, we replace them with one equivalent force. The magnitude of that equivalent force is always the area under the load diagram. Let's start with the simplest case, a rectangular distributed load. The load intensity is W and it acts over a length L. The equivalent force is the area of the rectangle. Therefore, the equivalent force equals W times L. Since the rectangle is symmetric, the force acts exactly at the center of the loaded region, which is L over 2. Next comes the triangular load. The load starts at 0 and increases linearly until it reaches a maximum value W0. The equivalent force is the area of the triangle. Therefore, the equivalent force equals 1/2 times W0 times L. The location is not at the center. Instead, the equivalent force acts 1/3 of the length from the larger side, or 2/3 of the length from the smaller side. This is one of the most important locations to remember in statics. Now let's look at the trapezoidal load. Many students think this is a completely new case. It is not. A trapezoid can always be split into a rectangle and a triangle. First, calculate the force from the rectangle. Then calculate the force from the triangle. The total equivalent force is simply the sum of both forces. To find the location, take moments using the centroid locations of the rectangle and the triangle. There is no need to memorize a special trapezoid formula. The key lesson is that distributed loads are really geometry problems. Rectangle means rectangle area. Triangle means triangle area. Trapezoid means rectangle plus triangle. Once you replace the distributed load by an equivalent force, the problem becomes an ordinary statics problem, and you can solve it using the equilibrium equations you already know.